which means it changes from any point in time. Okay? From any point in time. You don't know really, it's not like a constant thing. Okay, this is some of the practices for that. Well, I'm going too fast on these things, right? Okay, so now we look at PV cells and the different materials and processes, and a lot of the industry now is going actually making what? Building integrated type what? Photovoltaic cells. So it's actually it could be part of the building or part of the roof. Okay. Now we're going to talk about some of the technical parameters associated to a module. Okay. And I'm going to go a little bit slow. Okay. One of the most important, characteristics of those modules is what? The voltage and the current. Okay. Because once you apply sun into a particular panel, what do you get out of it? You're going to get a potential between 2 points. Potential is always made between 2 points, and there's going to be a voltage. The minute that you apply a load to it, then what do you have? You have a circuit which makes a current flow. Is that correct? Yes? We understand that. Okay. Now, so therefore, if I take a module by itself, and it's got 2 points associated to that, and I measure its voltage, what am I measuring up there? Something we call it what? The voltage or the open circuit voltage, right? Open circuit means what? There's no circuit associated with that. We plug in a what? Our meter. It's a typical voltmeter. Okay. A multimeter, so forth, and we will measure a voltage on it. Okay? So we call that the open circuit voltage because there is no load to it, so there's no current flow. So the current at that point is going to be what? 0, right? And what's the power? If I put a power meter across it, what am I going to measure? If I measure across the panel, if I take a panel like this, got 2 leads, I'm sticking the voltmeter up there and measure the voltage. What's the power of that particular? What is the current? And the current is going to be what? 0, right? 0. What's the power? It's going to be 0 power because of the Ohm's law says that the power associated is going to be what? The voltage times the current. And power can only be dissipated in what? In a device that it has in a load. Okay? So it's very important that we understand some of the characteristics associated because in that piece of electrical piece of equipment, what is our main concern? What is our main expectation? To get what? The output. And the output of a panel, that I buy a panel, is to get what? Power. Energy, right? Electrical power. Watts. So at some point in time, I have to get what? Current flowing into it and a certain amount of power across some particular load. Okay? All right. So if we take the voltage. Now let me ask you another thing. You take now the paneling here, and you have 2 little wires. Okay? And you want to measure the current associated with this thing. What do you do with it? You take the wires and do what? Hook them together. What happens then? What are you physically doing now? You short circuit what? The panel itself. So when I'm shining a certain amount of what? Light into it, and I'm actually generating a certain amount of what? Of voltage across it, by shorting the 2 leads up there, what would I have? I have a current flow what? Around the physical wires. Because the physical wires, no matter how good they are, they have what? Some resistance associated to them. So therefore, I have what is called an IR drop. So what do I have? I have a certain amount of what? Current flowing through there. Am I correct? Okay. So therefore, at this particular point, I call that particular current what? Short circuit. Short current. Short circuit current. Because actually, I'm shorting it out. It's sort of, what do you think is going to happen to the panels? Well, we're going to assume. Okay, think about it. Oh, by the way, did anybody figure out what makes the meter spin backwards? Nobody. Okay. Oh, man. Okay. Let's take it easy. Take it easy now. I didn't say anything to get anybody upset or excited. Take it easy now. Okay. So what happens, easy. What happens is we're gonna take these numbers up there, and the manufacturers sort of put these numbers into what? Into the actually specifications for reasons, okay? For reasons, because remember a couple things. We want to make sure that the amount of what? Radiance that we put to the panel, does it affect the voltage? Okay? Or does it affect the current? Yes or no? We have to figure out those things. Because what happens when you're shining lightning here? You're taking now this electromagnetic energy and you're changing it to electricity. What happens if you don't have 1,000 watts per square meter? What happens to the voltage? What happens to the current? What actually environmental conditions can affect that? Because the combination, or actually the product of the voltage and the current will give us what? The power that we need. And ideally, when we specified a particular module as giving us a certain amount of power, what do we want to make sure? That we get that amount of power. Because otherwise, something is wrong. Because once we take those modules and we hook them up in a peculiar way and we don't get the amount of power that we need, what happens? We promise the customer something, and what happens? We don't get it. All right? So what we do is we develop a method that we can actually plot, we can graphically show the relationship between the voltage and the current. And you say, why is that important? Because we'll see what happens, okay? So we put in what is called an IV curve, which is a current voltage curve, which typically, it gives you a profile of the electrical output. We could do that for a cell, we could do that for a module, and we can do that for what? For an array. It's easier to describe it in the terms of what? Of a module than going to the actually cell itself. By the way, I'm going to test a little solar light in here, just so you can get some idea where it is. Some you have seen. Is that clear so far? I haven't lost anybody. All I talk to you is what? That a module will give you a voltage and a current. Okay? Yeah. What happens is that we're going to repeat this over and over and over again, many, many times. Trust me. So if you don't get it the first time, you don't get it next week, you're going to get it by the time you finish this course. Because you're going to have those IV curves in your head, and you're going to talk about power and temperature and all this stuff. So relax about it. Nothing to worry about. So when you look at, and I'm going to show you this. By the way, do you have this handout that we gave you last time? Last time,